Continuing with confidence intervals. In 6.2, we're going to do confidence intervals of small samples. So we're going to use a t distribution. So remember, I gave you guys these t tables. If you don't have one, I'll give you one. But if you have yours, please get it. So we're going to learn about the t distribution. That's what that table is all about. And then we'll construct confidence intervals for a sample size of less than 30. It turns out that when you know your standard deviation, when you don't know your standard deviation of your population, sample size is less than 30, we can get a statistic, right, a standardized value, and we're going to call that t. It's going to be your sample mean minus your population mean divided by the, let's actually write this down real quick. That guy is your sample mean. Sorry. So this is your sample mean. And this guy right here is your population mean. This is sample standard deviation. And this is your sample size, right? For now, we're not going to really use this particular formula. We're going to use it in the future. But it's good to see and know what all of those symbols mean. For now, we're going to use that t distribution to find critical values of t. Just like we found critical values of z using the inverse norm, or we could use the z table. We're going to find critical values of t using our degrees of freedom and our confidence level. And we'll get into that here in a minute. So this t distribution, okay? It is like the normal distribution in a lot of ways. It has a bell shape, right? The area underneath it is equal to 1. The mean and the median are the same, and it is symmetric about the mean. What's different is that its shape depends on the degrees of freedom. Degrees of freedom is just your sample size minus 1, okay? You'll see that as your degrees of freedom increase, right, as you increase the sample size of a t distribution, it becomes more and more like a normal distribution. As the sample size decreases, you'll see the tails actually get fatter. In fact, I think that if Sir Mix-a-Lot were to do some statistics, t distribution would be his favorite because the tails are thick. And the next slide is just a little more describing what I was saying, all right? The total area of literally purpose 1, I said that. I said number 4. And then 5 is an illustration of what's going on, right? As your degrees of freedom get smaller, the tails get thicker. All right, so let's go ahead and find some critical values of t. First of all, if the sample size is 15, we got to first calculate our degrees of freedom. It's going to be sample size minus 1, so in this case, our degrees of freedom are 14. There are 14 degrees of freedom. This is what we're going to get out of this t table and use it, all right? So this slide has a interesting illustration. I'll also get out my table and we can look at it, right? So confidence level is 95%. So actually our table looks a little different. I like our table better. So we have a confidence level of 95%. So we're going to go down here to 95%. Our degrees of freedom was 14, right? It's 15 minus 1. So we'll find where these guys match up. And here we are. Our critical value, T sub C, is 2.145. Okay? 2.145. So that's, and there it is right there. All right. There's just a picture of what we found. It's not really necessary. This picture is not a necessary element. All right. So let's go ahead and find a critical value for a 90% confidence interval if the sample size is 22. If our sample size is 22, then degrees of freedom is going to be 22 minus 1, or 21 degrees of freedom. So we're going to go to our t table, and we'll line up the 90 degrees and the 21 degrees of freedom. It's not working at all. Okay. Let's go to 90, and then 21 degrees of freedom. We'll find out where they match. Okay, so 1.721. So T sub C was equal to degree, I forgot. 1.721. All right, so if we're going to construct a confidence interval, actually, this is the formula we're going to use. I'm going to give you a little better version of it, a little bit easier to understand. So we'll do x bar plus or minus d sub c, your critical value, times the standard deviation of your sample divided by the square root of your sample size. We're going to write down what all these things are. This is your sample mean. This is your critical value. This is your sample standard deviation. And this is your sample size. So this is just a process. I'll go through the process with you. I don't think we need to make it as complicated as this. But if you like this, it's fine. It'll be on the video. I prefer going at it a little something like this. Let's construct a confidence interval. Here we go. Let's do it. You randomly select 16 coffee shops, meaning that N is 16, right? You measure the temperature of the coffee sold at each. The sample mean temperature, in other words, X bar, is 162 Fahrenheit, but not important for us. The standard deviation is 10. Yep. And we're going to use 90% confidence for this one, okay? So I'm going to use that formula that I wrote down, X bar, plus or minus our critical value, times standard deviation of our sample divided by the square root of N. We're told that X bar is 162. We'll substitute that value in. We need to find our critical value. We're going to find our critical value looking at that T table, right? That T distribution table. So let's go ahead and do that. First thing we need to figure out is how many degrees of freedom. So our degrees of freedom is going to be sample size minus 1, which is 15. So we got to go to our T table. So on my T table, maybe I can erase some of this out. Come on. So we're doing a 90% confidence interval.
I got you. Go.
Alright. So how many degrees of freedom? Thank you. Did I just say? Learn it? 15. So you have 15 degrees of freedom and a 90% confidence. So our critical value is 1.753. Times our sample standard deviation, which is 10, divided by the square root of our sample size, which is 16. So we'll put this into our calculator. And I'll calculate this piece, which is actually our margin of error. So 1.753 times 10 divided by 4 is 4.39. So in order to construct my interval, it's the same as we were doing before. I'll do 162 minus 4.39, comma, 162 plus 4.39. Yeah. Okay. All right, so when I add that quantity, I get 157.61, comma, 166.39. And there is our 90% confidence interval. All right, now we need to do one. This 4.39 is, I calculated all of that. I calculated all of this. That turned out to be 4.39. Oh. And it turns out that this is also your margin of error, right? Your book refers to this as C. Alright, so now let's do the same process, but for 99% confidence, okay? 99. So at 99%, the mean stays the same, right? So x bar, plus or minus, we need to get a critical value. That's the only thing that's going to change. All of our numbers will be the same, except for this critical value. So let's go ahead and go to our table here. We'll go to 99%, and then our 15 degrees of freedom takes us to 2.947 is the critical value. 2.947. So 2.947 is the critical value, and then that's multiplied times my standard deviation of my sample divided by the square root of the sample size. So this is going to be 162 plus or minus. Let's go ahead and calculate that critical value, 2.947 times 10 divided by 4, which is 7.36. Now, in order to calculate this interval, first thing I'll do is subtract 7.368 from 162, which is 154. Let's see, 0.633. And then we'll go ahead and edit. $169.368, and there's our 99% confidence interval.
Really?
Yeah. We'll leave it right there for today, and then when next we meet, we'll do some more confidence intervals.